Okay, to solve an initial value problem, we're going to use integration on what is called a differential equation. Now, we may have explored this in the Do Now. What a differential equation is an equation that contains a derivative. So make sure that you write this down in your notebooks. Initial value problems provide you that differential equation and an initial condition such that you can solve for the initial value. Okay, so we're going to take a look at a couple examples and then actually check back with the Do Now to see if we can actually find our equations, and you don't have to just think, well, which is the initial condition and the differential equation. So let's go. Okay, so I left the last slide in case you were still copying initial value problems. We're going to take a look at example 1. Don't worry, I'm just going to read it first. The velocity v equals ds over dt of a body moving along a coordinate line is given. Find the body's position s at time t. And they give you v is 9.8 t plus 5, and s of 0 is 10. So the s of 0 is 10 is your initial condition. Okay, when t is equal to 0, then s is equal to 10, or its position is 10. Now, they don't have to describe this part here. You should be probably copying it at this point. Because you should know that your velocity v is equal to the derivative of position s with respect to time, so over dt. So we can replace v with that expression for which v is 9.8 t plus 5. So let's do that. Example 1. Okay, so ds over dt is equal to 9.8 t plus 5. Okay, so in order to use integration for a problem like this, we need to multiply both sides of our equation by dt. That is so we can eliminate it from the left-hand side of the equation and have it on the right-hand side of the equation. And we're going to integrate. So hopefully you can see, if we integrate this side of the equation, we must also do it to the other side, how this is an indefinite integral we can evaluate. It has to have the respect to t on the right-hand side. Now on the left-hand side, you may want to rewrite this as 1 ds, so you realize, well, if it's a constant, you need the variable next to it, and the variable in this case would be s. If you want, you can write a constant, because we always have to put a plus c for when we have indefinite integrals. Now, on the right-hand side, we're going to end up with 4.9 t squared plus t plus c. Now, if you think of the constant here as a different constant than here, then you can understand if I subtract it over, you're going to end up with a constant on the right-hand side. So that's exactly what happens. Try to keep your constants written only on the right side of the equation. That's helpful for other problems. But essentially, that's just, quite frankly, it. Even if they were the exact same amounts. And that means you're going to subtract it over and it's plus 0. Technically, 0 is also a constant. So you actually don't need this one here at all. Okay, so at this point, you will notice that you did find the body's position s at time t. It's a function t. But we need to still find out c. So that's where your initial condition comes in. We're going to replace the s with 10 and the t with 0. And we solve for c. Obviously, c is 10 in this case, so that is our position function. S equals 4.9 t squared plus t plus 10. Oops, I forgot to write in there. We solve for c to be 10. Oops, make sure that's in there. And we're done. Okay. Let's take a look at example 2. It's a little bit different. Again, if you didn't get something down, then please make sure that you rewind the video, got down what you need into your notebooks. So in example 2, the reason why it's different is saying find y, but they give you the second derivative because it's indicated by d squared y over dx squared. So we must first find our first derivative, okay, dy over dx, before we find y, okay? In that case, we need more than just like one initial condition. We need more than one. Be careful what you're plugging in where. I find that students end up like mixing the x and the y values or t and s values. So just be careful where you plug it in. Here we go. We're going to multiply both sides by dx. Now, you may not realize that there's actually 2 dx's in the denominator. It's actually all of dx that's being squared. Whereas in the numerator, it's actually a d that's being squared instead. And maybe by now you'll understand like the notation, why it is the way it is, because a d over dx is kind of by itself with dy, and we can integrate dy because it's like a 1 dy, okay? And it's saying it's going to be the derivative of this, which is giving us y, and it becomes dy over dx, which makes sense. Even if you didn't understand a notation part, that if you are taking the integral of the second derivative, you should get the first derivative. Now on the right-hand side, we should also integrate, and when we do, we get 2x minus 3x squared plus c. This is where you have to look for the y prime, or dy over dx. In this case, it said y prime of 0 is equal to 4. So we're going to replace this with 4 and the x with 0. And we find that c is equal to 4. This time I'm going to write it. And so now we know that dy over dx, or y prime, however you want to write it, is going to be 2x minus 3x squared plus 4. Okay? Now, you don't have to rewrite the order. It doesn't have to be ax squared plus bx plus c, nothing like that. You just have to integrate again because we still need to find y. So if I integrate, I'm going to multiply both sides of this equation by dx. So I'm integrating dy, and I'm integrating 2x, that's supposed to be 2, minus 3x squared plus 4 with respect to x. So I ran out of room. I'm going to have to erase this slide here. So y becomes x squared minus x cubed plus 4x plus c. So this is where the next initial value comes from. So y is 1 when x is 0. Again, please make sure you're plugging in the right places, like the right numbers. That's a 3, by the way. And we find that c is 1. So c becomes 1. And now we have our answer. Y is equal to x squared minus y cubed plus 4x plus 1. It's supposed to be a plus, and we're done. Now, I'm just going to go through the do now problems a little quickly, but at this point you are finished if you're going to explore do now, or maybe you solved it already. Please check your answers at the end of this video. And like I said, let me know if you have any questions. Okay, so in number 1 for the do now, so our derivative was sine of x, and we want to know y equals f of x. And it passes through the point 0, 2. So here we go. We're multiplying both sides by dx. We're integrating both sides. We get y is equal to negative cosine of x plus c. We're plugging in 0 for x and 2 for y. And cosine of 0 is 1, so it's a negative 1. I'm going to add 1 to both sides. C is 3. And my answer there is y equals negative cosine of x plus 3, or we could state it as f of x. So that's how we can use our initial condition and our differential equation. Okay, so number 2 in the do now, you had to identify the differential equation, which was dy over dx equals tangent of x, any condition. Even though it's not initial where t is 0, they're saying f of 3 is 5. We can use that to figure out our equation. Maybe the function is only plotted from when x is equal to 3 to infinity, so we have to use what they give us. Here we go. We're multiplying both sides of our equation by dx such that we can integrate both sides, take an antiderivative. And in this particular case, when we're integrating tangent of x with respect to x, we don't have a rule, but we do know the quotient identity for tangent of x is sine of x over cosine of x. So we can use substitution, try out the denominator first, and it works out nicely because the derivative of cosine of x is negative sine of x, write dx here. And all of that is going to be replaced with a negative du. You take the negative out in front of the integral, and now we realize this will its antiderivative is negative ln absolute value of u plus c. But u was cosine of x, so we're going to have to plug that in. And I'm running out of room, so I'm going to try squeezing it in over here. So y is equal to negative ln absolute value of cosine of x plus c. Now we can plug in the 3 and the 5. So let me actually plug in the 5. Negative ln absolute value cosine of 3. This is not an angle like pi over 3, so we can't use our special right triangles to figure that out, but we can use our calculators so we can get an approximate answer for C. Okay, so 5 plus the ln of cosine of 3, and we end up with meaning the absolute value. Don't forget that. I wrote it, but then I didn't type it into my calculator. And that changes things, hopefully for the better. Okay, so if you enter in at once or even do it piece by piece, as long as you refer to the last answer, you can get about 4.990. Have the 0, so you show you did round appropriately to 3 decimal places. And you're good to go for writing your answer. Y is equal to the negative ln absolute value of cosine of x, or it's an approximate, plus 4.990. All right, good luck.